All right, looking at this question here, derivatives of a logarithmic function. Suppose we have a function which is some constant times our logarithmic function, so logarithm of 2x plus b, where fe equals 3 and f dash e equals 6 over e. So this is saying we have this coordinate, the graph goes through a coordinate e and x, and at that point it has a slope of, it goes up 6 as it goes across E, I guess would be a good example for it. We don't really need that stuff. I'm just trying to put that into context for this problem. But the most important thing really is, first step, we need a derivative. So we've got two equations. So we take the derivative of this function. So f dash of x will be, now we're looking here, this is just going to be a log. We've got a constant at the front. So we've got a stays out the front. And then the derivative of a logarithm is the derivative of the inside of the bracket. So it's going to be 2. And then it's going to be over 2x plus b. All right, so we're sweet here now. So we can put our two equations in. So we've got f of e. So I've gone back to my original function, not the derivative function. And I've got f of e equals 3, which means f of e also equals a ln 2e plus b. And that equals 3. So therefore we've got, I'll do it as separate because we've got them as separate. Therefore, a ln 2e plus b equals 3. And then if I use my other equation, which is this one here, I've got, also, I've got f dash of e equals 6 over e. And then if I put e in this equation up here, I've got f dash of e equals let's simplify this a little bit, get rid of some of these brackets. We've got 2a over 2e plus b, and that's going to equal 6e. So therefore, 2a over 2e plus b equals 6e. All right, so there's a couple of ways we can do this. At the moment, I look at this and I think when we did this one in class, I sort of look at this and I think, I would multiply this by 2 over e, both sides. And the reason I would do that is it would make this side here equal to 3. And so then I've got, I'll continue this way, it's just easier. So 2ae would be my top here, and then I'd be 4, not a bracket, 4e plus 2b, and that would equal a ln, I'll do it in steps. I'm worried I'm going to jump too far. So this would equal 3, and therefore this here, this and this are equal because they both equal 3. So I can then go, therefore, I would usually work down, a ln 2e plus b equals 3. Not equals 3, we don't want to bother with the 3 anymore. We're going to go equals 2ae all over 4e plus 2b. All right, so I'm going to, if I pull the 2 out of this, I'm just going to divide by both sides by a. So I'm going to divide this side by a and this side by a. So they're going to cancel, they're going to cancel. And then I've also got a 2 on the top here and a 4 and a 2. So that's going to be, my next line here will be ln 2e plus b equals e over 2e plus b. All right, I'm going to times by 2e plus b, so I get 2e plus b ln 2e plus b equals e. Now, this is going to be the weirdest bit of this solution. I'm going to raise this using my log laws, 2e plus b to the power of 2e plus b, and this equals e. Okay, and this is, the rule I've used is n log a equals log a to the n. I'm just writing it in a general form. All right, now the next step is we're going to raise both sides to an e. So I'm going to put this to an e and this to an e. So what we get here is we get these two cancel out, and so I'm left with 2e plus b and 2e to the power of 2e plus b. Now this equals e to the e. The kicker with this is we can equate parts because we've got this is a base and this is a power. They have to be the same. So that means that 2e plus b has to equal e from this, and this method is called equating parts. And so then we've got 2e equals e minus b. I'm then going to take e from both sides. I get negative b equals positive e. So b equals negative e. Hang on a second. All right, so we've got b equals negative e, which if we think about it makes sense up here because we're looking at, I'm just going to change colour again. Let's just go to this. We're looking here at when we had fe, it equaled 3, and we're looking at, well, this will be a ln 2e minus e equals 3. That's going to give us ln e times a equals 3. ln and e cancel out. We've actually got a equals 3. Now, we can sub it back into this form as well, just to double check. So we've got 2, we've got a equals 3, and 2e negative, not times, take e, means we're going to be left with 6 over 2e take e is just e. It's a big tick. We've got those answers there. So this is the move that's really confusing in this one, called equating parts. So there we go with that one. Thanks.